Good morning students. Today we will study class 9th chapter 10, that is gravitation. In previous lecture we had studied about the universal law of gravitation. In today's lecture we will discuss about free fall. So as the name indicates, a body is falling from some height without any extra force. For example, as you see, a stone is fall from the certain height. On the other side, a feather is fall from the other side, from the height. So there is a difference between the falling of stone and falling of feather. So in falling of stone, the speed of stone is very high. On the other hand, the falling of feather has less speed. So here we will discuss how the free fall is involved in this process. So the free fall, a body is falling from certain height is said to be free fall body if there is the only force of gravitation that is occur on the body. If the only gravitational force is occur on the body, then we can say that it is free fall of the body. During free fall of the body, there is no change in direction. So as the body falls from a certain height, under the influence of gravitational force, there is no change in the direction of the force. Since there is no change in direction of the force, but there is change in speed or velocity. So here the speed and velocity must be changed during free fall of the body. As you know, if the velocity of the body changes, then we call it as acceleration. So change in velocity of the body involves acceleration. So the acceleration which is under the influence of gravitational force is called acceleration due to gravity. So this is what is acceleration due to gravity? If the body falls towards the earth due to the gravitational force, then we called it as acceleration due to gravity. Here the acceleration due to gravity is denoted by g, that is small g. In previous lecture we had discussed about capital G. I will give you the difference between small g and capital G later. So since it is acceleration due to gravity, it is just acceleration. So we can say that its unit is meter per second square. So mathematically we find the formula of that g. As previously we know the acceleration is change in velocity per unit time. So but on the other side in terms of gravitational force we will write as the force is applied on an object which is dependent on the mass and acceleration. From Newton's second law we know that force is mass into acceleration. So here I can use the acceleration as g because here we are talking about acceleration due to gravity. That is number one. So number two, as we discussed in previous lecture, the gravitational force is given by Gm, that is mass of earth, small m, that is mass of any object on which the gravitational pull is occur, and d square, that is the distance between object and the gravity or the earth. So that is d square. This is equation number 2. On comparing equation 1 and 2, we get mg gmm upon d square. Here the m cancelled, we get g is gm upon d square. This is the expression for small g, that is gm upon d square. D is the distance between the object and the earth. So if we are talking about the object and that earth, that distance is the d. If the case 2, if the of Earth. So here is the object. Then we taken as D is R. So here we can write G is Gm upon R square. So R is the radius of the Earth. You can see if the object is on the surface of the Earth, then this is the radius. This is the formula for the acceleration due to gravity on surface of Earth. So here point to be noted that G is directly dependent on the mass of the Earth. It doesn't depend upon the mass of the object. So as the object is heavy, lighter, the value of G is never depend on that object. This is always depend on the value of mass of Earth. Here it is R. R is the radius. G is also dependent on R. So as we know, the Earth is not spherical as well. The Earth has different radii on equator and poles. So we know poles to equator. We know the value of radius of Earth increases from poles to equator. I am sorry, here is equator, here is poles. So value of radius of Earth increases from poles to equator. So G becomes greater at poles because the radius of equator is greater than radius of pole. So if the radius is greater, the value of G is lesser. So G of E is less than G of P. So G becomes greater at poles than G at equators. So is that clear? So we can say that if the value of R is greater, then the value of G is smaller. So here the value of G depend upon mass of Earth. So we can calculate the value of G not only on the value on the Earth, but also can calculate the value of G on any celestial body, on moon, sun and other planets also. So the value of G depend upon mass of any heavenly body. Next is calculation of G. What is the value of G? Here we can calculate. We know G is Gm upon R square. So value of G we are known, that is 6.7 to 10 raised to power 11. So mass of Earth. So mass of Earth is 6 into 10 raised to power 24 upon radius of Earth is 6.4 10 power 6 whole square. So by calculating these things, we get the value of G comes out to be 9.8 meter per second square, or approximately we can take it as 10 meter per second square. Is that clear? Is that clear? Okay. So the value of G for Earth is 10 meter per second square. Clear? So here the next we will discuss about the difference between small g and capital G. So what is the difference between small g and capital G? Firstly, G is the acceleration due to gravity that is acted on a body due to gravitational pull. Capital G is the gravitational force which is taken between the two masses having unit mass and having one distance apart. Next is a value of G is constant, that is 9.8 meter per second for Earth, but on the other planets the value of G can be changes. But the value of capital G is remain constant throughout the universe. So next, the value of G at the center of the Earth. Here you can see at the center. If the object is at the center, the radius is 0. If the radius is 0, then the value of G is also 0. Or not defined. We can say it is not defined. So at the center, small g is 0. But the capital G can't be 0. Its value is constant. And second is the value of G decreases when we go deep or when we go high from the earth surface. If we go from the earth surface high or if we go on toward the surface of earth, then the value of G decreases. But the value of capital G doesn't change. The value of G is different for different positions. As you see, for poles and equators, the value of G is changes. It's not the same as 10. So, but the value of capital G doesn't change. So, small g is calculated by this formula and the capital G is calculated by from this formula. As you know, we had done it yesterday. In previous lecture, we had done it that the value of G is calculated from different formula. That is universal law of gravitation, and formula for small g is this. So here is the difference between small g and capital G. So next is motion of object under the influence of gravitational force of earth. As in previous chapter, we had done the motion, chapter motion, in which we had done the equation of motions. That are three equations of motion. I will recall you. S is ut plus half at square, v is u plus at, v square minus u square equals to 2as. We had done these equations. As if the motion is described under the gravitational force, then the acceleration due to gravity is changes to acceleration of the object is changes to acceleration due to gravity. So here we will change the value of A with G. So the equation becomes V is u plus gt, S is ut plus half at square, gt square. Here we had write gt square. So A changes to G. V square minus u square is 2gs. So these equation of motions are under the influence of gravitational force. The later we had done, that is the not under the influence of gravitational force. These are the equations which are under the gravitational force. So while using these equations in numericals, we had done the numericals in next lecture. While doing these equations in numericals, firstly the things kept in mind, u should be 0 if the object is fall from the certain height. If the object is fall from the certain height, then we can take u is 0. Got the point? If in numericals they said a body is falling from the certain height, then the value of u is 0. The initial velocity is 0. If the object is thrown upward at the highest point, if the object goes at highest point, then the final velocity is 0. Because when we throw a stone upward, it takes a few seconds or milliseconds to stay there at rest. So V is 0. So while doing numericals, that things kept in mind. One more thing, that G also be minus. So G can be negative also. That is minus 9.8 or minus 10 also. And this can be done, as I told you, the value of G decreases as it goes up away from the earth or towards the earth. If the body falls upward, goes upward or falls down, then we can say the G should be negative. These are the sign conventions that are given for the use of small g. We will discuss about these sign conventions in next chapter while doing the numericals. Thank you.